Okay, hello everyone. Let us now proceed with the example. Okay, so let's read the problem first. The three boreholes were sunk to a vein of ore, and then the depth of the three holes at the points A, B, and C and the surface measurements connecting them are: elevation of surface at A is 4,750 feet, the depth of the hole at A is 3,500, and the elevation of the surface at B is 4,920, and the depth of the hole at B is 2,860. The elevation of the surface at C is 4,790 and the depth of the hole at C is 2,080. And we are given the azimuths of AC, AB, and CB respectively from south. Okay, so we also have a horizontal distance here from A to C of 1320 feet. Okay, we are asked to find the bearing of the strike and the dip of the vein. Okay, so the first thing that we can do is subtract the depth of the hole from the elevation of surface at the points, so that we will get the elevation of the intersection between the plane of the vein and also the borehole at A, B, and C. Okay, so let's just subtract those. So A, so let's just denote it as A here. Okay, so 4,750 minus 3,500. So that would be 1,250 feet. How about B here? So for B, we have 4,920 minus 2,860, and that will give us 2,060 feet. And then for C, you will have 4,790 minus 2,080. You will get 2,710 for that. Okay, so as you can see here, the lowest point is A, right? And the highest point is C. So, if we remember the 3D system, 3D coordinate system that we need to do, the highest point should be along our vertical axis. So C should be along our vertical axis. And the lowest point should lie along the the horizontal plane. Okay? So it is useful to get the difference between these two. So the first is B minus A. So this is the second highest point minus the lowest point. So we will get so 2,060 minus 1,250, that would be 810. And then 2,710 minus 1,250, that would be 1,460. Okay. And then for the azimuths, so the azimuths right here, so it is useful to draw them in 2D first before proceeding to drawing them in 3D. Okay, so let's draw them in 2D first. So let's say this is our point A right here. And then the azimuth from south to C is 60 degrees and 22 minutes. So let's try to draw that out here. So this is C right here. And then A to B, that would be 80 degrees and 30 minutes. So that's somewhere here. So B. And then for C to B, that is 140 degrees and 20 minutes. So about here. So I already drew this before I recorded this video, so I have an idea of how it looks already. Okay, so this is the 2D representation of the azimuths. So let's proceed now to our 3D plane right here. Okay, so let's draw the elevations of the intersection of the boreholes in the plane of the vein first. So from the origin to C, so C is along our vertical axis, so that would be 1,460. So let's just estimate 1,460 to be about right here. So that is 1,460 feet. And then the second highest point should be along our Y. So this is our Y, and this is our X, and this is our Z. Okay. And then so that would be B, and B should be along our Y, right? So that is 810 from my horizontal plane. So this should be around here. So just an estimate. Okay. So this is 810, and then our A. So if we so let's say our north north is about faces here. Our north is in this direction. Okay, say this is our north. Okay, so let's draw this. So if this is our north, okay. Okay, so just to help us to draw, no? And it's our A here. Let's just estimate the location and see if it fits. See if C is here, if A is there. See if our north is here. Like that. Somewhat like that. So the azimuth from A to C should be 60. And A2 should be 80. So it's just about right. Okay. That's cool. So this should be our approximate location of our A. And this is C prime and B prime. And this is our C and this is our B right here. This is C. Okay, so now let's connect the points so that we will see the vein, orientation of our vein. Okay, so now we have our vein. So the next thing that we need to do is we need to project this so that it will intersect with the horizontal plane and also the Y here. Let's project it. Okay, that's about right there. And then our strike should be right here. Oh, sorry for that. Okay, so there you have it. So this is our intersection of the plane of the vein and the horizontal plane. And intersection with the y-axis, let's call that point D. Okay, so now let's start computing for the angles in the triangle A, B prime, C prime. Because as we've discussed in the previous video, right, we need those three angles. So as for angle A right here, so let's write that out in the figure first. So this is our angle A, this is our angle C, and this is our angle B. So let's start with angle A. Let's compute it in the top right here. So our angle A is equal to the azimuth of A to B prime, or A to B, minus the azimuth of A to C prime, right? So if we compute that, we will get 80 degrees 30 minutes minus 60 degrees and 22 minutes. So that will give us 20 degrees and 8 minutes. So how about angle B? So let's project the A to B prime azimuth here. Okay, so if this is our south, here, and this is our north. So this should be this angle here. Wait, just a minute. This angle here should be the same as the azimuth from A to B prime, right? Of course. So this should be 80 degrees and 30 minutes And if you subtract that, if you subtract that from the azimuth of C prime or C to B, the azimuth from C to B is this one right here, right? So if you subtract that, subtract 80 degrees and 30 minutes minus the azimuth from C to B, so that would be, so what's the azimuth? So 140 degrees, 20 minutes minus 80 degrees and 30 minutes. So B will be equal to 59 degrees and 50 minutes. So this will be the angle here, and this is equal to this one. Okay, so that's B. And to calculate for C, that's basically 180 minus B plus A. Okay, so if you calculate C, you will get 100 degrees and 2 minutes.